The next question is access control. In this question, check listed is co-chef office, and in co-chef office, all those need a swipe access card, and the swipe card allows fixed number of swipes. So we will be given a string of length n and an integer x, and if the value is the string is 0, then swipe value becomes reduces by 1, and if it is 1, then it's reduced to x. So we need to find whether the given string is a valid string or not. If it is a valid renewal string, if we can access all the doors using the swipe card, and initially the swipe access value is 0. So if you look at the sample test cases, the first test case is 0, 3, 1. As initially the value is 0, he can't proceed to the next door. So the answer is no. And for the next test case, it is 1001. Initially, the value swipe is 0, but the index 0 is 1. So the swipe value become equals to 2. So he can access the value at index 1, and the value reduces by 1, and he can move to the index 2. Here the value reduces by 1, and when he reaches the last index, the value is 1. So it reduces to 2 again. So by this, he can access all the doors. So the answer is yes.
So yeah, let's see how we can solve this question. So let's take a sample case, right? So in this case, the n value is 5 and the x value is 2, right? And so in the first move, our number of swipes is 0. So when we come across 1, it will be renewed to 2, right? At this point, the 2 will decrease to 1. And at these both indices, again, it will renew to 2 itself. And at the last point, again, it will go back to 1, right? So the point where where a chef is not able to make a move, the number of swipes will basically kind of try to go below 0, right? And that is not possible, right? So basically, a renewal character, which is 1, should come before all the swipes are exhausted. Okay. So from this, we can observe and tell that the number of consecutive zeros should never exceed the value 2. Okay. Or never exceed the value x, I will say, as a generalization. Okay. So if we have, let's say, a string like this and x value is 2, right? Here the number of zeros are 3. The number of consecutive zeros are 3, right? So after being renewed here, it will try to decrease 3 times, but we have only value 2, right? So in this case, it will not be possible, right? So we can break this question down into some cases. The first case, we can say that if the very first character of the string, let's say a string is like this 0, 1, 1, no matter how many ones we put afterwards, if the first character itself is 0, then in that case, it would not be possible to open the first door as well, because initially the number of swipes are 0, right? So what we can do is, let's take a string. Let's take a string like this, 1, 0, 0, 1, 0, 1, 0, 0. Okay. And let's say that the x value here is equals to 2. Okay. We'll take a variable swipes. We'll initialize it with 0. Okay. And now we start from the beginning of the string. If we come across 1, we'll say swipes, we'll rewrite the swipes with the value x, which is 2 in this case. Okay. Now we came to the first point. If we get a 0, we'll basically decrease this value, right? We came here, again we got a 0, so we decrease it 0. Now we came here, we got a 1, so we'll renew it to 2. Okay. We came here, it's 0, so we decrease it to 1. It's 1, so we renew it to 2 again. Then we come across 0, we decrease it to 1. We come across 0, we decrease it to 0, right? Even if you get 2 ones in a row, it will still renew to 2 only, it will not add. Okay. And so yeah, this is how we do it. So what we observe in this slide, in this case, it's possible because at no point the value became less than 0, right? But let's just do the same thing and let's say this was 0 instead. Okay. So what would happen is, so let's write this again, right? So what would happen is, in the first move, it would become 2. In the second move, it would become 1. It would decrease to 0 now. And at this point, it will basically go -1, right? So what we need to do is, after every move, we just make a check whether the value is going below 0 or not. If at any point, if it goes below 0, then we just straight away say that, no, it's not possible for such a string to exist, and this string is invalid, right? So yeah, this is how we solve the question. The time complexity will be O of n, right?